Hi, pre-calculus friends. We're in section 1.8, the last section of this chapter, and we're going to be talking about graphing linear inequalities. An inequality would be any kind of mathematical expression where you would exchange like an equal sign for an inequality sign. And we know inequality signs can be greater than or equal to, less than or equal to. Sometimes people even include this, but this is not really a thing for us to be talking about right now in terms of the just not equal sign. So generally when we're talking about linear inequalities, we're talking about something like this. And a linear inequality would be one where the relationship or the inequality kind of looks like a linear equation if you replace the inequality sign with an equal sign. When we talk about half planes, it's the idea that when you graph, it really comes from the idea that when you graph a linear inequality, you'll be graphing it on the coordinate plane, the XY plane, as we would any line. But then that line that's related, let's say I'm going to graph this. Let's say I graph this situation here. That line that is related to the inequality, in this case, y equals 2x minus 5, I'm going to do a quick graph. The minus 5 is my y-intercept. I'm going to start there. Up 2 over 1, up 2 over 1, up 2 over 1. That's going to be my slope. And that's going to be the line, barely, that is associated with this inequality. And if you notice, this line has cut the plane into two spaces. We've got on top of the line and below the line. So when we talk about half planes, we recognize that when we are graphing linear inequalities, when we're graphing lines, but specifically with linear inequalities, we recognize that it's important to identify the two half planes that are created. Because those half planes, I said I'd finish this problem, those half planes make up part of the answer. So this inequality is y is greater than or equal to 2x minus 5. Therefore, since y is greater than or equal to, the equal to is a part of the answer. That means the line is. And then greater than, we would shade above. There's a couple ways to talk about how I know to shade above. But for me, my real quick way of doing it is I just say y is greater than this line. And if y is greater than this line, that means that y is everything that's greater than in terms of y would be above the line. If it were less than, it would be below. We're going to have a solid line here because y is also equal to that. But if we were to take off the little equal to down here, we would end up having to have a dotted line. And so we'd have to go back and do something like that. Because the boundary, and that's what this is here, the boundary that we're talking about would not be a part of the graph. So the boundary is the line that we draw that is related to the inequality. We know that when we're dealing with inequalities, we need to pay attention to the two half planes that are created by drawing the line. And a linear inequality is just a linear equation with an inequality sign. Let's get started with some problems. Since we're referring to this as linear inequalities, so we're going to look at this x not as like x on the number line where we used to graph it like this. Let me see. We would like have the 3 here and do like an open circle shade to the right, and that would be the answer. We're going to graph it like a linear equation on the coordinate plane, on the xy coordinate plane. And so we know the related equation here, I'm going to do that in purple rather, would be x equals 3, which we know to be a vertical line crossing the x-axis, perpendicular to the x-axis at 3. And so that's the graph that we have. But since this is just a related line, let's go back to the inequality. It says that x is greater than, but not equal to. There's no equal to there. So I'm going to have to make this a dotted line, the boundary that I've now created. Notice that I've split my coordinate plane into two boundaries, one to the left of the line, one to the right. And now we need to determine what they're saying. It says that x is greater than 3. That means, where is x greater than? It's x greater than to the right. And so we're going to shade everything to the right. So the graph of this linear inequality would have that dotted boundary line, and everything to the right would be shaded like forever. So half of the coordinate plane is shaded. This next one we're going to do in blue. The first thing I would do here is I would solve for y. I'm going to get y by itself. And so what I'll do is I'll move everything to one side, and everything except for the y term rather, to one side, and then move everything else back, all right? not back, but you know what I'm talking about. Solve for y, children. Solve for y. So we have 2y, move the x over to the other side, move the 5 over to the other side, is less than or equal to negative x plus 5. Notice the 5 and the x change signs as we move over. And now we're going to divide both sides by negative 2. When I divide by a negative number on both sides of an inequality, I need to change that sign. That sign flips over. So I'm dividing by negative 2. That goes away. Sign changes, and over here I'm going to have a positive 1/2 x. Think about it. If I divide this negative 1x by negative 2, I get a positive 1/2, or a positive x over 2. And then over here I get a negative 5 over 2. And so I've got my equation or my inequality in kind of a slope-intercept form. I'm going to write the related equation here, and I'm going to graph that. I'm going to start at my y-intercept, which is negative 2.5. That's that negative 5 over 2. So here's 3, here's negative 2.5, and now I'm going to go up 1 and over 2. 1, 2. There's a point. Up 1, boom, and over 2. 1, 2. And here's a point as well. And so this is the x-axis, and I'm going to draw my line. And now I'm going to just ask myself, should I draw it solid or dotted? It's got to be solid because it is or equal to. So I've got my line drawn nice and solid there. There we go. And now I've got to determine where am I shading above or below. Now, your teachers in the past may have told you, since you've cut this into 2 coordinate planes, or two planes, 2 half planes, you choose a point on either side. Let's say this side, the origin. You plug it into the inequality. You see if it's true. If it's true, then that's the side you shade. If this point satisfies this inequality, then you shade that side. If this point does not satisfy that inequality, then you shade the opposite side. I'm going to tell you that you can do that, but I really just look at y is greater than the line. Y is greater than the line means I'm going to shade above. And so therefore I'd shade above. And what you'd find is that the 0, 0 would have worked in the inequality, as this is the side that is the solution to that inequality. All right, and so this last one is an absolute value equation, right? Or the related equation is an absolute value equation. And so we have y is greater than, well, let's use the equation. Y is equal to the absolute value of x minus 2. We talked a little bit about this last time, and when we discussed absolute value equations and we did piecewise functions and all of that, we talked about finding the lowest point of the graph because we know that this is a V. And if you have to plot out an XY table to kind of plug it in, that's okay. I'm going to show you what I'm going to do. I know that as the equation stands here, the lowest that y could be is 0, as y is equal to the absolute value of some stuff. So the lowest that y could be is 0. So what I'm going to do is look for where y could be 0. Y is going to be 0 when x is equal to 2. So I know that that's a point. And now I'm assuming that that's going to be my most bottom point. Now I'm going to prove it to myself by plugging in some other numbers. If I put in a 1 here, 1 minus 2 is negative 1. Absolute value of negative 1 is positive 1. If I put in a 3 minus 2 is 1. Absolute value of 1 is 1. I see I get that bending and that V situation, which is exactly what I want. And I can continue plotting some points, and I get my V looking like this. However, I recognize that this is an inequality. It's going to be a dotted V. You guys get why? Because it's not and equal to. It's not or equal to. And now I'm going to treat this just like I did before. Y is greater than this thing. Therefore, I'm shading above. And so yes, even this absolute value V splits the plane into 2 distinct parts, and you can see that's what happened with this graph. Example 2 is going to refer to some information that we were given in the beginning of the chapter. So let's go ahead and check that out. We're looking at Arctic explorers who have to use endurance and strength as they're pulling really large or heavy sleds that weigh upwards of 1,100 pounds. For 12 hours a day. And so one of the important bits of information we need to know is that they could burn easily 4,000 to 6,000 calories per day. And now we're going to be thinking about 2 different micro or macro nutrients. One is fat, and endurance diet has a balance of fat, carbohydrates, and protein. So we're going to look at carbohydrates and protein as one thing and fat as another thing. And the reason why is because fat is a concentrated source of energy and produces or supplies 9 calories per gram. Sorry, I'm saying crazy stuff, y'all. Stay with me. Okay, and then on the other hand, carbohydrates and protein together, um, well, each of them, whatever kind, will produce 4 calories per gram. And so that's the bit of information we're going to use to look at this the first question. And so down here it says, refer to the application at the beginning of the lesson, which we just read over, and draw a graph that models the combination of grams of fat and carbohydrates and protein that the Arctic team diet may include to satisfy their daily caloric need. So with the details written down here, I'm going to get started thinking about maybe let's call X the number of fat calories or the number of fat grams, and we know there's 9 calories per gram of fat, and let Y be the number of carbs or protein, and we know that there are 4 calories per gram of a carb or protein. And so we know the team needs 4,000 to 6,000 calories a day, so that would look like this. We know that that's 9x plus 4y. And again, the number of grams multiplied by 9 will give me the calories from fat, and the number of grams of protein or carbs times 4 would give me the calories from carbs or proteins. And so the next thing I know is that I need the amount to be somewhere between 4,000 all the way up to 6,000. So this is the inequality that we're working with here. And so this is hard to graph as it is, but if we broke it down and looked at it as 2 separate inequalities, graphed it and see the overlapping space, we'd have a better chance of graphing this. So I'm going to break that down now. The first thing I did here is separate the 2 inequalities. So instead of having it written like this, I've got it written like this. It's an equivalent statement. Now I'm going to solve for y in each of the half inequalities in a sense. So I put both of these in a type of slope-intercept form where I've got y is greater than or equal to -4 over -4 at -9/4 x plus 1,000, and y is less than or equal to -9/4 x plus 1,500. So now to graph that, so I set up this table and I'm going to graph based on color. So I'm going to highlight this graph and this inequality and this one. So what I'm going to do is actually graph these by X and Y-intercept. The Y-intercept is really clear for this blue inequality. It's going to be 1,000. So I'm just going to put a little blue dot there. And then the X-intercept is a little bit harder, but when I plug in for 0 and I solve for X, I actually get 444.4. So that's going to be somewhere just shy of 450. So the other point is going to be here, and I'm going to carefully try to draw this line. So this line is a part of the graph because it's or equal to, and in this case, I'm going to be shading above because y is greater than. Are you guys with me? I hope this makes sense. So I'm going to shade above just like that. And so that will be my answer. But remember, 2 things need to be in common. I can't just have one. I have to have both of these because this is an and compound inequality rather. And so now I'm going to graph this pink one by doing exactly the same thing. I'm going to start with the y-intercept, which clearly is right there at 1,500. And then when I solve for the x-intercept, meaning put a 0 in for y and solve for x, I end up getting 666.66 continuing. So that's going to be somewhere just about here. And then so I'm going to draw this line like that. And when I do that, I'm now going to shade. But notice I'm shading downward here. So my inequality is going to be shaded in this direction. So I'm going to start here and shade down. So what's the answer is what you're probably asking, and I'm glad you are. It's going to be the overlapping region. So to make it a little bit clear, I'm going to try to fade out some of this other stuff here so you can't, and that's not it, so you can't actually see what's not the answer. So all of this I'm going to just get rid of so you understand that the answer is the shaded portion right in between these 2 lines here, okay? Okay, so I know it's not super pretty, but I hope you get the idea that the answer is right in here where I'm highlighting in deep yellow. And so the final thing that we need to do is name 3 combinations of fats or carbohydrates and proteins that meet the caloric requirement. And any 3 points that you would choose within that section would meet that caloric requirement. So choosing any 3 points, figuring out the grams of fat and the grams of protein and or carbs that make it would work for this answer. Take care.